Here, this is Kauyan Stoyanov from Coventry University presenting his 8-pool OpenGL game. I will demonstrate what my game does, and then I'll jump into physics and graphics respectively. So, pretty much to play the game, you have the ball, which is moving on its own, and you press space to multiply its speed. You can also, while doing that, manipulate the camera in any way you would like. It is restricted to 180 degrees view. You can increase the speed of the ball as much as you can. It's unlimited. But also, you can decrease it. As you can see, all collision is there, just no score system just yet. And I will meet you on the other side. Here, I will lead you through the graphics and every part of it. So first of all, we have the ball, which is created by constantly creating circles around it with vertices which act basically like the connections of those circles. The ball has stacks which are actually those circles and slices which have many connection points. The ball also has an applied texture. Second of all, the table. Other than the applied texture, and looking really good, excuse me, the table is created by multiple vertices being pinpointed to certain points and being one whole table, pretty much. So third of all, we have the shaders. The first shader we have is a vertex shader. The vertex shader changes the position of the vertex. It may also determine the vertex's color. We have also a pixel shader. The pixel shader determines the final color of a certain pixel. It does that by using light, materials, and so on. How it works is we compile a vertex shader and a fragment shader, and we get an ID. At this time, we check for compilation errors. Once we get those two IDs, we link them together, and we get the shader program. That as well returns an ID, and that ID is really important. We keep it, and we use that ID before we render anything on the screen. For example, in the upper part of the screen, you can see a vertex shader. It has a variable S downscore V position, and a little bit lower you can see we have a void main, which is the entry point of that shader. Down below, under the line, we have a fragment shader with the same entry point. In this case, we say that the final color is red, regardless of lighting or materials. Some of these functions we are going to be calling. The ones you see here are the ones we use to create and compile vertex shaders. After we declare which shader we want, we have to list its source before we compile. After the textures are initialized, we create the window. Textures are done by first setting a parameter for them and then binding the texture to a certain point. Then we filter those points, which will help us reduce black spots appearing on the texture after it's executed. Then we clear it. After its texture, we delete the previous to free up space and prevent compilation errors. Thank you. This was all from me. You can find my details in the description, and also my references in the description. Thank you very much. Enjoy your night or day, or whatever you're having.